Hi, everyone, and welcome to PyData Global. We are excited to have you join us. Please feel free to use the chat to connect with fellow attendees and share your thoughts during this session. If you do have any questions, please post them in the Q&A tab, and we'll address them at the end of the session. Now, it's my absolute pleasure to introduce Nicolò Giso. Nicolò is passionate in data science and machine learning, involved in projects from ETL through modeling to deployment. So please help me give a warm virtual welcome to Nicolò. Nicolò, take over.
Thank you, Patricia. Hi, everyone. Today, I will present you how with image recognition, we made the steel factory floor more safe in Tenova. A brief overview. So basically, I will give you a short background of what Tenova does and the use case, what is the basically the context, and then we will go in the details of machine learning and talking about Python. So the training and the deployment, and finally conclude with some takeaways on this project. So let me introduce myself. As Patricia said, I'm Nicolò. I work as a lead data scientist in Tenova digital team. And you can see on the left some of my major skills that are basically making memes and copy pasting, and some of the stuff that I accomplished in this year. And today I'm happy to be here with you presenting our project. But now let's see what Tenova is. Probably not many of you know Tenova. Tenova is a company that works in the steel industry, in the metal and steel industry in particular, and produces furnaces and roll grinders for steel makers, basically. Our four pillars for developing solution are producing machineries that reduce cost, save energy, limit environmental impact that in those days is fundamental for us, and finally improve working condition. This is the last point just in order of speaking, but for us it's really important indeed. Our solution that I will present focus on making the condition of people working in the steel factory better. Okay, now let's see the use case. So as I said, we provide furnaces for steel shops, and here you can see the use case is the detection of bulky scrap on steel. What is a consteel though? A consteel is basically a conveyor belt that moves back and forth in little movement in order to send the scrap metal inside the furnace to be melted and then produce new metal. That's a way to make more ecological steel, basically, because you don't go with other technology, and we are able to be, our customer have less environmental impact. Anyway, one of the point is that on this steel there could be some bulky piece of scrap that I will show some example in the next slide that could hit the electrodes of the furnace and create problems. Indeed, the motivation that for which we started this project was to avoid production stop and equipment damage, because you have to think that when a bulky piece of scrap hits one of the electrodes inside the furnace, besides breaking the electrode, and so is an expense to replace it in the ten of thousands of dollars, there is also production stops. That this translates in roughly as a estimate in $1,000 per minute of stop. So you can think the time to replace it, it will be over half an hour. So it's many dollars that go wasted. But the critical and very important thing is also to avoid health problems. For one of our customers, we customize and tailor the solution to detect, in particular, hazardous material. And so that's why we make the safety floor of steel plants better and more safe. Now let's start talking about the training of the model. So the model architecture that we choose based on previous project and our experience was ResNet 50 as a backbone to extract the more important feature from the images we collected, and then train a custom neural network on those features to classify the images of the constill. Now I give you an idea of what type of images you can expect. The three categories are those in which basically we have large sheet of scrap and wire rods that are considered bulky piece of scrap. And then we have all the others. So you can see smaller pieces of scrap that will have no damage whatsoever on the production and especially on people. So we started to train the model. We had many pictures actually above 30,000, but we made a selection. Indeed, we were able to sample every 10 seconds from the constill a new image. But the thing was to don't have images that would be really equal. So we discriminated with some function in order to have a good distribution of possible outcomes. And with the first model that we trained, we got an accuracy of 85%. That is a pretty good result if you think about the fact that the class with the largest percentage is by default 55%. So a 30 increase on the, let's say, baseline benchmark. But then we placed our solution in production, and what happened is what we call the empty constill issue. Basically, our model wasn't able to distinguish between large sheet, one of the category that is considered bulky, and so as is a problem, with the empty constill. Indeed, the constill itself is, as I said, is a conveyor belt, and so it's made of the same material of the bulky scrap. And you can see it's pretty similar. And it wasn't just the model that thought they were similar. Even an experienced person in the field of steel could mistake a little bit the two pictures. So what we have done, it was to rework on our data set to create to take in consideration also the empty constill pictures that we have not considered in the first training set. And we remade the training using again 5,000 images, sampling in a different way this time. And now replacing the old model with this new one, we hit 96% of accuracy. And that was great because we are able to confidently help people on the field. So that was the part on the model training and how we have done it and prepared the model. But as I say, a model that is not deployed is not so useful. So let's talk a little bit about deployment. I want to focus a bit on the limitation that we have in Steel Factory, because many of machine learning that we hear in those days are basically with full connectivity and run on the cloud, on the cloud platform many times. The thing is that steel plants sometimes do not offer connectivity for two main motivations. The first one could be the customer that doesn't want to connect to the internet for some fear of cyber attacks or just because it doesn't like to make stuff in a new way. And the other point is that some plants are basically in the middle of nowhere where there is no connection. You have to think not many places in the world you have in the city center a steel plant. So the connectivity could be an issue. And also we need low latency. So we have to have an answer in matter of milliseconds, I would say around 300, 400 milliseconds. And so we couldn't wait to send our request to the cloud with all our data flow that we have currently with our solution. So fortunately, we have an industrial PC that we dubbed Tenova Edge that basically is a solution that we propose that basically reads data from any plant data source and writes the read variables and telemetry, both on premise on the customer side, but also on our platform to be analyzed and help the customer. And the important point for our use case is that can also machine learning models on IoT Edge modules that are basically Docker contains with a tiny wrap of Azure Microsoft software. So here is some of the lines most important for the prediction for the deployment. And on the left, you can see the code for the init function, and on the right, the one for the run function. In just a few words, the init function is needed to load the models, the configuration, and for models, I mean both the ResNet and also our custom model, while the run is basically the function that is run when we have to make a prediction. Okay, here I call this slide architecture, but it's really easy anyway. We have a level 2 that is the computer that calls from the automation system our model, and in our first version of the model we use HTTP framework, and we use protocol, and we use Flask as a framework for hosting the model, the machine learning model. So we get a request for the level 2, we make the prediction, and we send back the response to level 2. So here you can see the Flask app powering this service. You can see it's really easy, but it's really powerful for our need. Basically, we have a logger, so we can log all the information. And then we have the function to initialize the models, and then the function for the prediction. So basically arrives in this function for the prediction, it arrives the image in a JSON with a base64 format. We deserialize the image, throw the image in the ResNet backbone to extract the feature, and then make our prediction out of the feature with our custom neural network, and send the JSON back with the result. So that was our fourth solution for the deployment. Then we move to RabbitMQ. What is RabbitMQ? Actually, some months ago, I didn't know what it was, but then my colleague helped me in knowing it. It's basically a broker, and is a reliable way for sending and distribute messaging and streaming system. And it's really useful for our scenario because we work in with IoT data, and having the possibility to broadcast the information, it's really powerful. So my colleagues the part of the team in my team, they focus on the part for the platform, and moved all his code to use RabbitMQ for higher robustness. And the way RabbitMQ can work is, out of the many ways, the most important for us are the topic and the RPC. As you can see directly from the documentation of RabbitMQ, the topic way is for broadcast messages. You can see there is a producer that throws a message on a topic queue, and a consumer receives it. And there is basically no direct communication between the producer and the consumer. The producer just produces and throws the message, and the consumer subscribe to a queue to receive the message and use it. The other way to use it is the RPC, that is the perfect solution for one-to-one communication, because there is a client that calls a server. The frame of our RabbitMQ wakes up, gives a disposition for a queue, and then the server replies on this queue with the answer. So the first solution is perfect for streaming the messages around in our solution, while the RPC would be perfect for our machine learning solution. So in our team, we implemented a library that uses RabbitMQ using .NET, that is the main language used on our solution. And this library is basically an abstraction layer over the basic RabbitMQ framework because we need just some functionality, and we don't want to expose too many stuff and details. And this library is a higher level library that allows friend devs to be able to run RabbitMQ without knowing the nitty-gritty details, and that's really useful. So after we were ready, we had RabbitMQ on all the parts of our Tenova Edge, except for the part calling our machine learning models. We decided to make the porting of uh, also the part with our models. So the idea was to use still RabbitMQ and replace the HTTP with RPC. Basically, we're making the RPC request from the level 2 to the machine learning module, and then give back a response. So here is a screenshot. I hope it can be understood. Otherwise, I will try to explain it a little bit better later. But anyway, the idea is to use Pika, that is the library that RabbitMQ proposed to use the framework with Python. And basically, we use this as a first solution that allow us to register a server and then make all the hosting of the machine learning model, receive a request from the level 2 and give back the response in an asynchronous fashion. But we felt that we need something more than that, because we need something with higher robustness. Indeed, on the documentation, there are some lines saying that the Python library is perfect for many scenarios, but it doesn't allow out of the box for stuff like reconnection. That is something that we have to provide in our industrial setting. And also we would like to have higher level library without having the devs in the team to know all the details of how subscription queue topics work or RabbitMQ. We would like to export something that was easy to use. And finally, there was the third point, that we want something battle tested, and we without being starting from zero. And the fact that I was going to write the library in Python for zero, it was a good point to find another solution, basically. And so we had an idea. We know the Python Net existed, and we thought, why don't you use Python Net, since we have the .NET library ready and working. It's been working for, I would say, a couple of years now. We have that on one side, and there is Python Net that allows to use the .NET libraries inside Python code. Let's try to use this solution. And so we basically make a wrapper around the C# library, and to make it a little bit more Pythonic. Otherwise, using the same method name would be really obnoxious, I would say, for a Pythonista. And here you can see the really short code, but it does everything that we need. Basically, we take all the information from the environment variable to subscribe to RabbitMQ, so the host name, the username, and the password. And then we set up the Rabbit in an asynchronous fashion using and making the registering RPC server that so allows to use the model from the level 2. And there we have to register an handler that basically is a function that whenever receives a message, triggers the function and then send back the response. So it's perfect because whenever the level 2 calls, it gets a response right away. And here you can see in a few lines of code, okay, some of are written in the library on the top, the Tenova Rabbit library. We were able to build a reliable app and solution also with Rabbit. So to wrap it up, this is a dashboard showing how it works. It's in Italian, the title, because our customer in this case was Italian. Basically, it says detecting bulky pieces of scrap. And here you can see how it works. Basically, on the level 2, on the HMI, we have this dashboard that signals with green when everything is okay. So the pieces of scrap are compliant, what we expect. While when there is some problems in this instance, are wire rods, there is a red flag. I would like to show you a video, but I wasn't sure I was able to show you today, but we'll try to explain what it happens in this video. So basically, there is an automatic system that whenever there is the red flag on an image, throws an alert, a notification on the HMI to the human operator, and the human operator can say, check that that's real a problem and is not an error made by the machine learning model. So we integrate the human in the loop strategy. And there, when he just pushing a button, is basically starts all a procedure to stop the movement of the conveyor belt and discarding the anomalous piece. And so after this, it can go on without problem. And to conclude, I will also briefly talk about 3 takeaways of this project. One is the evergreen one that is people that work on data science project know really well, but I would like to repeat, is that it's important to familiarize with the data, because we have seen the empty conceal issue is just the tip of the iceberg, but no, just iterating over and over on the data, you get to know better what to model and make better models. Then the robustness of RabbitMQ is perfect for IoT scenarios, such as is our case. And finally, it was great to use PythonNet in an industrial product for seamless integration between a C# library and our Python code. And that's it. If you have any question, I'm here. Thank you.
Thank you so much for that presentation. I'm going to go ahead and put, we do have a question in the Q&A tab, so I'll go ahead and present that on the stage now for you.
Okay.
Let me know if you can see it okay.
Yeah, I can see it. Thank you. For a real-time streaming, okay, how does Flask perform for a real-time streaming inference? I would say it performs really well. For the Flask application, we actually use, wait a sec, in the first scenario, we were use Windows, so it was with Waitress as a backend to provide the needed power, let's say. And then we use another kind of server, NGX server, to be sure that it was going to work. And the performance were around, with the given hardware that we had at the moment, it was around 300 milliseconds. So it was kind of great, I would say.
All right. It looks like currently we don't have any other questions. Did you have anything else you wanted to add? We do have about 7 minutes remaining in this session. Any last minute questions, feel free to add them now.
I think it's time for coffee.
I'm gonna have to agree. All right. I think it looks like we're good to go. If it's okay with you, we can go ahead and wrap up this session.
Yeah, would be perfect.
Okay, perfect. So thank you all for joining us today. If you'd like to continue the discussion, you can head over to our Discord. The link is available in the reception area. A recording of the session will be available shortly after for rewatching. And for those interested in a more casual conversation, we do have the lounge open in the reception for those smaller group discussions. But again, thank you, Nicolò, for this great presentation, and thank you
much.
all for attending. We're going to go ahead and end it.